Section 5.7, the natural logarithmic function integration. So in this section, we're interested to find integration of log function. By the end of this section, you should be able to use the log rule for integration to integrate a rational function, integrate trigonometric function, log rule for integration. So we know the derivative of the log function is 1 over x. So integration of 1 over x supposed to be ln absolute value of x plus c. Remember, log function is only defined for the positive value. That's the reason we are putting this absolute value sign. Okay, and then instead of x, if you have u, you can apply the same rule. Okay, so what's the integration of 2 over x? By using the very same rule, we can say the integration of this is 2 integration of 1 over x 2 times ln absolute value of x plus some constant. So that's what we have the formula here. Okay, but there is a property of log function. We can bring this to here and we can write ln absolute value of x squared plus c. You no more need this absolute value because of this square, so we can also write ln x squared plus c. Because x squared is always positive, so you don't have to worry about the absolute value sign. So that's the reasoning we have here. Okay, so let's try to do this one, 1 over 4x minus 1 dx. So this type of problem we can substitute here, this one. Let's say u equal 4x minus 1, and then you can find the du, meaning just differentiate both sides, and then it will give 4 times dx, and derivative of 1 is 0. So dx is du over 4. So if we do this substitution here in this problem, our problem now becomes 1 over u, and instead of dx, we can write du over 4. This 4, we can keep that 4 outside, so that's 1 over 4. And then now we have du on the top and u on the bottom. So we can use the standard formula, which is ln absolute value of u plus some constant. Keep in mind, finally we need to plug the value of u back, which is 4x minus 1. And then eventually the answer would be 1 over 4 times ln absolute value of 4x minus 1 plus c. So here is the answer for that. 1 over 4 ln absolute value. Inside the absolute value 4x minus 1, we don't know either that 4x minus 1 is positive or negative, so that's the reason we have to keep that inside the absolute value. Here is another problem. Find the indefinite integral, and here is the hint, using long division. So we can use the long division for finding the indefinite integral here. So first of all, divide x squared plus x plus 1 by x squared plus 1. That gives us this 1 plus x over x squared plus 1, and then after that we can use the substitution for this x squared plus 1, and we can change this into log problem like this. So after division we get 1 plus x over x squared plus 1. We can split this into two different problems. One is the integration for the 1, and another one is integration for x over x squared plus 1. Here we're just adding extra 2 and 2 here because if you just substitute u equal x squared plus 1, then du is 2x dx. So to replace this 2x dx by du, we're just making this 2x on the top. By doing that, this problem will change into this problem will change into 1 over half du over u, 1 over half du over u. And that's the reason the integration of this part is half ln x squared plus 1, because u is x squared plus 1. Keep in mind, x squared is always positive, and adding 1 gives you always positive number. That's why we don't need absolute value sign here. So when we try to find the integration, some of the tips we can apply. First of all, you need to learn a basic list of integration formulas. And then after that, find an integration formula that resembles all part of all or part of the integrand, and by trial and error, just try a different approach. Find a choice of substitution for u that will make the integrand conform to the formula. So like we did in previous examples. If a substitution that works cannot be found, try altering the integrand. Try a trigonometric identity, multiplication, division by the same quantity, addition and subtraction of the same quantity, or sometimes long division. Users have to be creative. Users have to try here and there. Check the result by differentiating to obtain the original integrand. This is the most, always after finding the integration, if you just differentiate that, it's supposed to give you the original function. Okay. Integrals of trigonometric functions. So these are the formula for integration for the trigonometric function. By using the antiderivative, we can find the integration. So you have to just write down this formula on paper again and again, and then it's a good idea to have this formula. If you remember it, that will be perfect. Okay, here's the one problem. We have to evaluate integration of the square root of 1 plus tan square x plus tan square x dx. And look at this formula, and if you find anything directly which can be used to compute the integration here, square root 1 plus tan square x, there is nothing like this. So what we have to do, we can always play with the trigonometric function, and we can change this 1 plus tan square x into different trigonometric function if it's possible. So just try to do that. 1 plus tan square x is actually, tan square x means it's a sine square x over cosine square x. So sine square x over cosine square x, and if you play with that, that will give you, I can just make it sine square x over sine square x for the 1, and on the top, cosine square x over cosine square x here for the 1, and that will give us cosine square x plus sine square x over cosine square x. Okay, and then eventually that will change this 1 plus tan square x into secant square x. So that's how we can change this problem into secant problem. This integral does not fit any formula on the basic list. So first of all, change this 1 plus tan square into secant square x. By doing that, now this problem looks familiar, So square root of secant square x is secant x. And now we do have the formula. If you go back and check the formula list here, you can see that this is the formula we can use. The integration of secant of u is ln, absolute value secant of u plus tan u plus c. Okay, and because of that, this is the integration. And by using the fundamental theorem, first of all, replace this x by pi over 4. And that gives us ln square root of 2 plus 1 by using the value for secant pi over 4 and tangent pi over 4, minus ln secant 0, which is 1, and tan 0, which is 0. So ln 1 is 0. So that is our value for integration. If you use a calculator, then this is what you are going to get approximately.